Alright, so let's start with this one. All those who are here the last class, remember your goal is still to get theta by itself. What would your first step be? Okay, let's step back. Assume there's no 4 theta here. Assume this is just theta. Assume this is just theta. How would you solve an equation like this? What would your first step be? What is the first thing you'd look to do?
Get it all on one side.
Get it all on one side, yes, because what are you trying to do here? No, you're right, absolutely right. What are you trying to do here? Actually, you don't even have to get it on one side. Actually, I'm going to take it back. You don't want to get it. You don't want to take it all on one side, because you would do that for a quadratic if it's to get in the standard form. This is actually a linear. If I didn't even have 4 theta, keep in mind what your goal is. Your goal is to solve for theta. Your goal is to solve for theta. If the theta is nothing like your x, when you're first solving for your x, what is the first thing you look to do? To isolate the x, right? To get that x by itself. To get that x. So your first step will be to isolate the term that contains theta. Everybody good? Because remember, you're trying to solve. Whenever you're trying to solve, your goal is always to get that term by itself, to solve for it. So here my goal is to get cosine 4 theta by itself. Can we all do that? You will move the 5 to the other side, and then you will divide by 2. What will you get? Everybody good? Negative half? Please stop me if it's not clear why we got that negative half. I move the 5 over to the other side, becomes negative 1. Negative 1 by 2 is negative half. Then what's your next step? Again, if this was just theta, what would you have done? If it was just cosine theta equals to negative half, how would you have solved for theta? Perfect. I would look at my unit circle, right? I would look at my unit circle, find out where is the value of cosine, negative half. You will do exactly the same thing. So the first couple of steps is going to be the same. You will isolate the term that contains theta. You will look at the unit circle to what are the solutions for negative half. Can we just write down the 2 angles here? I don't want to write it down because you want to write it down as 4 theta. But for now, tell me, when is cosine theta equal to negative half? Okay, so for this, everybody needs the unit circle out. And you should really be not waiting for me to write the answers. You should start looking at the unit circle and find. The more familiar you are, the better you will be at doing your work. So what are those 2 values of, what are those 2 angles where cosine theta equals to negative half? Everybody good? 2 pi by 3, 4 pi by 3? Because cosine theta is half at pi by 3, but then you want negative, it's at 2 pi by 3 and 4 pi by 3. So normally under normal circumstances I would have said theta, if it was just theta, equals to 2 pi by 3 and 4 pi by 3, but I will not do that. So what will I do? I will, instead of saying just theta, I have to say 4 theta. So 4 theta equals to 2 pi by 3. And then at some point I will reduce the 4 theta to 4. And please leave some space because I have to add something here. And then my second solution is 4 theta equals to 4 pi by 3. So far I have not done anything that's different from what I already know of solving a linear trigonometric equation. Everybody good? Isolated the term and then looked at the unit circle to find my angles. Okay, so remember what I said? Because the value of B is 4, my wave is compressed. It's actually compressed. 0 to 2 pi, there will be 4 waves instead of just 1 wave. So there are so many more solutions. So for me to find those multiple solutions, you do something called add 2 pi k. So this is the new thing. You will add 2 pi k to both the sides where k equals 0. It's an integer starting from 0. That's what your value of k is. So this is the new step, where you add 2 pi k to your solution to find the other solutions. Because you're looking for solutions within 2 pi. You're looking for solutions within 2 pi. Okay, remember what I said? I'm trying to solve for theta, but I have 4 theta. I'm trying to solve for theta, but I have 4 theta. So you will divide the left hand side and the right hand side by 4. Dividing by 4 is the same as multiplying by what? 1/4. Right? It's easier to multiply by 1/4 rather than divide these two terms by. Everybody okay so far? Everybody's... Okay, I'm going to go ahead and simplify this. There are two equations that I need to work with. I'm going to go ahead and do the first one first. So this will just be theta. And then both of these are multiplied by 1/4, so you distribute. What is 2 pi over 3 multiplied by 1/4? 2 pi times 1 is 2 pi. 3 times 4 is 12. I know I can simplify it. Do not. Just leave it alone for now. And I'll tell you why. And then you multiply 2 pi k over 1/4. 2 pi times k times 1 is just 2 pi k. And the denominator is just 4. I know we can simplify, but don't. For now, just leave it. Just keep it simple. Multiply it. Just do that one step and leave it. Can we all do the other side? Same thing. Don't simplify. Just distribute the 1/4 and tell me what you get. Again, please stay ahead of me. Don't wait for me to do the work. Is everybody good so far? Is there anything here that's not clear? Is there anything that you want me to explain? Okay, then what will I do? I can start substituting for k because I have theta by itself. So for me to get my solution, I can start substituting for k. I can say k equals to 0, and then I can say k equals to 1, and then substitute. The only problem is when I start substituting for k, right, I have to add these two. Not for k equals to 0, but from k equals to 1, 2. I have to add these two. So you're getting into adding fractions. And you're getting into adding fractions where the denominators are different. So you'll add fractions multiple times where the denominator is 0. So you'll keep doing finding the common denominator. So it's easier to do that once before you substitute for k. Then it becomes so much easier to solve for k. So the next step is going to be make them have the same denominators. So what will you do for them both to have 12? You will multiply top and bottom of this with 3. Everybody good? Alright, so let's do it. Let's go ahead and I'm doing the left hand side. Theta equals, leave this alone, there's nothing to be done. But this one you will multiply top and bottom with 3. Because you want them to have the same denominator. So how do you do that? So 2 times 3 is 6 pi k. 4 times 3 is 12. Okay, so I've got what I worked towards. They have the same denominator. My life will be so much easier now when I start substituting for k. And you'll see that. You'll see that. Can we all do it to the right hand side? Same thing. Please make them both have the same denominator. Again, don't wait for me. Please do the work. Everybody okay? And then now we are ready to start substituting for k. K equals to 0, k equals to 1, k equals to 2. But how far do I keep substituting? When do I know I have to stop? Remember your restriction. Your restriction is find all solution from 0 to 2 pi. So ideally you need to stop at 2 pi. Ideally, and we know 2 pi because if you're working with the unit circle, we know that everything on the unit circle is 2 pi. But not when we have fractions which are not, these are not on the unit circle. So how do I know when I have to stop? So theta needs to be less than 2 pi which is when I take, so when I'm working with a fraction of 12, for it to be 2 pi, I multiply my numerator by 2, so it's 24 pi. So theta needs to be less than 24 pi by 12. And that's going to be true for every problem. There will be some problems where 9 will be the denominator. When 9 is the denominator, numerator will be 18 pi over 9. There will be times when, I don't know, 8 is the denominator, then it will be 16 pi over 8. So basically you have to make sure that when you calculate for your angle, it has to, and you'll see as we start calculating, the answer is going to get closer and closer to 24 pi by 12. The minute it crosses 24 pi by 12, you need to stop substituting for k. Okay, let's start. It'll obviously get clearer when we start working. So k equals to 0, you want to start with k equals to 0? When k equals to 0, theta equals to what? If k equals to 0, you guys can first just listen to me and then do the work. This second term is going to be 0. 6 pi times 0 is 0. So this term is so it's just going to be 2 pi over 12. Everybody good? I'm so sorry. Wait, I read. Yeah, 2 pi over 12. But 2 pi over 12, at this point you do want to simplify. So your actual solution is, the first solution that you solved is pi over 6. That's the first solution. You're going to, yeah, everybody okay? Going to continue with the same. K equals to 0. This thing vanishes, so it's 4 pi by 12. You don't have to write theta again, you already written. It's 4 pi by 12, which is actually equal to 4 over 12 is pi over 3. That's your second solution. Is everybody okay with the first set of solutions? So I have two solutions so far, pi over 6 and pi over 3, but I'm going to keep going. I'm going to take k equals to 1. Theta equals to, can we all do that without my help? Substitute for k equals to 1. 6 pi times 1 is 6 pi. 6 pi plus 2 pi is 8 pi. And remember, it's so easy for me to add because they have the same denominator. Alden, Tristan, why are we on the phone? Can we all focus? It's got a lot of steps, so we should all be working. All right, thank you guys. Okay, so you want to substitute for k equals to 1. So 6 pi times 1 is 6, so 6 pi plus 2 pi is 8 pi. So my answer is going to be 8 pi over 12. So again, like I said, my life is easier because they have the same denominator. What is 8 pi over 12? They're both factors of 4, so 2 pi over 3. Okay, can we keep going? Substitute for k equals to 1 with this equation. Four pi plus 6 pi is 10 pi, so 10 pi over 12, which simplifies to, both of them are factors of 2, so 5 pi over 6. So far I have four solutions. So far I have 4 solutions. They're all within 2 pi because my denominator is still within, it's 10 pi over 12. 10 pi over 12 is less than 24 pi. Okay, keep going. K equals to 2. Can we all do k equals to 2 without my help? Six times 2 is 12. 12 plus 2 is 14. 14 over 12. What does it simplify to? My next set of solution is, okay, I'm going to go ahead and write down the solution. You see if you got this when you substitute for k equals to. Okay, for k equals to 2, those are the two solutions you should have got. Please do the work of substituting for k equals to 2. See if you get those two solutions. Again, please stop me. Please ask me if it's not clear. So hopefully we all got. This should have been 14 pi over 12. And this should have been 6 times 2 is 12. 12 plus 4 is 16 pi over 12. I'm still less than, remember where I should stop?
24.
24, perfect. But I'm still at 16 pi over 12. So I need to keep going. I need to keep going. So let's do k equals to 3. Can we all do k equals to 3 and see what we get? So remember, this is the equation that you're working with. If you want to highlight it so that you know which equation you're working with, please do that for different case substitution. 6 times 3 is 18. 18 plus 2 is 20. So 20 pi over 12 simplifies to, they're both factors of 4. So 5 pi over 4? Over 3? Sorry. So 20 pi over 12 is getting closer to 24 pi over 12. But let's do the right hand side also. 6 times 3 is 18. Yeah, very good. 6 times 3 is 18. 18 plus 4 is 22. The only common thing is 2. They don't go in, so it will be going to be 11 pi over 6. And that's probably my last, because 22 pi over 12 is really close to 24 pi over 12. It has to be less than. So when if I go take to k equals to 4, 6 times 4 is 24. I can't even go there. So I need to stop right here. So I have how many solutions? 1, 2, 3, 4, 5, 6, 7, 8 solutions. You do have a question like this on the test. I will tell you right away. It has a lot of points because it's a lot of work. So please make sure you are following it. Please ask me questions if you're not sure. Tristan.
You always have to start with 0.
Yes, you always start with 0. Because that is a solution. That is a solution. Yeah, perfect. Yeah. Is everybody good? Okay, it is like I said, it is a lot of steps. I would like us to practice one more if you have time. We'll see. I do need to teach you one more thing before so I'll see. But what I'm going to make you do is I am going to make you guys write down the steps for these so that when you do this problem, you can look at the steps and see what are the different things that you're doing. Can I remove this sheet of paper? Is anyone still looking at it? Just raise your hand. I will wait. Okay, moving this and yeah, okay. We're removing this and we're going to go ahead and write down the steps for doing this thing. Find some space where you can write about 4, 5, 6 lines in your notes. If you don't have space, I have scratch paper. I'll be glad to walk around and give you one if you want to keep it as a separate scratch paper because you don't have space somewhere in your notes. Do that. George, you can just come and grab one from my desk. But I'm going to go ahead and start. Okay, so this is 2 steps for multiple angle. Solve for multiple angles. Okay. Step number 1, remember what we did? So just go back and look at the notes. You're given an equation. Where it's a multiple angle like this one, right? Like what we just did. Your step number 1 was to isolate it, and that's what we're going to do. We said let's isolate the term that contains theta. So isolate the term that contains theta. Oh, I'm so sorry here. Those of you who don't like writing too much, you're also welcome to take a picture of it at the end if that makes your life easier. But some of you may like to write it out, so go ahead and write it out. So isolate the term that contains theta. So once I got cosine 4 theta by itself, I looked for my 2 angles on the unit circle, right? So look at the unit circle. And find the angles. The minute I say look at the unit circle, I'm sure all of you will understand what you're talking about. Look at the unit circle to find the angles that satisfy that equation. And step number 3, write the angles, or depending on how many angles you found, mostly you'd have found 2, as n theta, because it's 2 theta, 3 theta, so on and so forth. So n theta equals the angle that you just found plus 2 pi k. Here we go. Write the angles as n theta equals angle that you just found plus 2 pi k. Is the third statement clear? This is the one where you say 3 theta equals 4 pi by 3 plus 2 pi k. 3 theta equals 5 pi by 3 plus 2 pi k. And if you look at your notes, the steps that you've done, you'll be able to match it to see, okay, this is what I did, this is what the step means. So it's kind of hard to write the equivalent of what you're doing, but if you look at what you've done, it should be clear. Okay, once we got that, once I said 4 theta equals to angle plus 2 pi k, reduce the n theta to just theta. Right? That's what we did. We divided both sides by 4. We divided both sides by 4. So reduce n theta to theta. And I'm going to write here, solve for multiple angles. When we say multiple angles, we're talking about n theta. So that you know what we're talking about here. And remember, you have to reduce n theta to theta in the left hand side and the right hand side. You're going to reduce n theta because there are two equations. Make sure you do it to both the sides. Make sure you do it to both the sides. And then once I reduce 4 theta to theta, I have this equation, but I notice that I do need to start substituting for k, but I notice that they have different denominators. So your next step is to make them have the same denominators. So step 5, make fractions have same denominator. Oh, hi. Yeah. Everybody good? Once they have the same denominator, which was this step, remember I multiplied top and bottom by 3, and I got the same denominator. Now I can start substituting for k. Start substituting for k. Stop when theta is less than 2 pi, will be in fraction. So hopefully you understand when I say will be in fraction, you can figure out that if the denominator is 9, you're talking about 18 pi over 9. If it's 12, you're talking about 24 pi over 12, and so on and so forth. Okay, I'm going to leave this up for a minute or two for those to finish writing. Take a picture of it, whatever works for you. Yeah. Okay, does anybody need a little more time on this? Just raise your hand. No, very good. Okay. Since I made you guys write down these notes, I would like us to do one more problem. That way you can follow the steps that I've given and work on it independently. So I'll give you guys about 5-7 minutes. I'll show you the work. So let's all work on 3. Let's just read it. Cotangent 3 theta plus square root of 3 equals to 0. So the first step will be the same. What does it say on your notes for the first step? You have to isolate the term that contains theta. So you will get cotangent 3 theta by itself. And then you look at the unit circle. That's what it says in your notes. Look at the unit circle to find the angles. The only thing is this is cotangent theta. We don't have that on the unit circle. We have sine, cosine, and tan. Yes? So what you want to do is you want to rewrite it as tangent by taking the reciprocal. So why don't you guys start? I will just do the first couple of steps so that I can show you that, so that you're on the right track to make sure that you're rewriting it as tangent. But first step is isolate. Go ahead and do the isolation. Please work on. So this is one problem. We're going to work on it independently. I'll just show you that one step where we have to rewrite cotangent as tangent, which all of you do know. It's not that something you don't know, but I just want to make sure you're on the right track. So we're doing number 3. So let's all isolate. And then we're good? Isolating. At this point you would have looked at your unit circle to see when is the value of cotangent negative square root of 3 or just square root of 3, and then you look at the negative coordinates for cotangent, except I will rewrite this as tangent. Can we all rewrite this as tangent? So when I rewrite this as tangent, tangent 3 theta equals what? Reciprocal, right? Everybody agrees with me? But when you have a reciprocal with a radical in the denominator, you want to rationalize, because on my unit circle it's always rationalized. So you won't see this on the unit circle. What will you see on the unit circle? You multiply top and bottom and you actually have negative square root of 3 over 3. This is what you will see in the unit circle. So this value, when you take the reciprocal of this, is negative square root of 3 over 3. I'm trying to match what's on the unit circle. Is everybody good so far? Okay, now can we all finish it up? Now just follow the steps that I made you guys write and see if you can do this independent of me. And any step you're getting stuck, you're not sure, please call me. That's why we're doing it in the class, so I can help you.